Okay, so today I'm gonna do May-June 2023 chemistry paper 4-2. Okay, so this paper, right, I'm gonna discuss and also do some recap so that you guys can actually revise and remember what you guys have actually learned. Okay, so we start with question 1. Okay, question 1 is, okay, there's a list of oxides and now they're asking you which of the oxides A to H is responsible for acid rain. So when you look at acid rain, right, there are two main things that you have to remember. So first one is sulfur dioxide, another one is oxides of nitrogen. So if the question there is carbon dioxide, is it the main contributor? Is it one of the contributors, direct contributors to acid rain? The answer is no. It's indirect, it's not direct. So the direct contributor is sulfur dioxide and oxides of nitrogen. So based on this list of oxides, we have sulfur dioxide, so it is D. Okay, second question is, has a giant covalent structure. Okay, so giant covalent structure, we can have a look here. So which one has a giant covalent structure? Obviously it is silicon oxide. So the answer is C. Okay, so to add on this, it's what's the chemical formula of silicon oxide? Okay, so we know that the oxidation number here is 4 positive, whereas oxide it is 2 minus. And when we do the crossing charges, so it would be this way. So when we cross the charge, it's gonna be Si2O4. Is this the final answer? No, it's not the final answer because you can further simplify it. Okay, so you can actually divide it by 2, and you get SiO2. So this is the chemical formula for silicon oxide. The next question is, which of the following oxide is a reducing agent in a blast furnace? Okay, so a good reducing agent based on the list here, it would be carbon monoxide. Okay, carbon monoxide is actually a very good reducing agent. So carbon monoxide, it can be used to reduce iron trioxide to form iron. Okay, so this is kind of like a redox reaction over here. So whereby carbon monoxide is gonna reduce iron trioxide to form iron, whereas iron trioxide will be acting as an oxidizing agent to oxidize carbon monoxide to form carbon dioxide. Okay, do you get it? Okay, I'm gonna write the equation here. Okay, so we have iron trioxide, so we have Fe2O3 plus carbon monoxide, which is the reducing agent. Okay, so this reducing agent is gonna reduce iron trioxide to form iron. Okay, so this is the reducing agent. So reducing agent, you have to know that reducing agent is gonna reduce iron trioxide. So redox reaction is like this. We have one reducing agent and we will also have an oxidizing agent. So this oxidizing agent, which is referring to the iron trioxide, is gonna oxidize carbon monoxide to form carbon dioxide. Okay, so of course we can move on by balancing. So balancing here is we're gonna put 2 in front of iron because we have 2 iron here. Okay, so the next one we can, okay, so we have oxygen. Oxygen is not balanced, so we can put 1 3 here and we can put 1 3 here. And right now it is balanced because we have how many oxygen here? 3 6 6. Yeah, okay, this is balanced already. Okay, so the reducing agent here is carbon monoxide, so we have to put H. Okay, which is the main constituent of bauxite? Okay, so bauxite, right, you have to remember bauxite, it is always aluminium. Okay, so bauxite is aluminium. So we have aluminium here. Yes, we have aluminium oxide. Okay, because aluminium oxide is the main constituent of bauxite, so it is B. Okay, so there's another one more that you should know. It is called hematite. He, hematite. Okay, we can have different spelling. It can be like this also, hematite. So hematite, what's the main constituent? You have to remember that hematite is for iron, bauxite is for aluminium. Okay, the next question. Which of the oxide is the main impurity of iron ore. Okay, the main impurity for iron ore is silica. One of it is silica. Okay, so silica is referring to which one? It's actually referring to silicon oxide. It's the same thing. Okay, so silicon oxide, it is C. Okay, the next one can be reduced by heating with copper. So if copper wants to reduce something, of course the something there has to be below copper in the reactivity series. This is actually a displacement reaction. So what is below copper in the reactivity series? We have silver, we have gold. Okay, so based on here, we have silver oxide because silver is below copper in the reactivity series, which means that copper can actually reduce the silver oxide. So the answer has to be G. Okay, next question. Okay, so we have fluorine, or you want to call it fluorine, it's the same. Okay, so I'm going to say fluorine, chlorine, bromine are in group 7 of the periodic table. So group 7 elements, we have another name for it. So what's the name? The name is halogens. Okay, this one is, you have to remember. Okay, so explain why group 7 elements have similar chemical properties. Okay, so this is a very frequently asked question. Why they have similar chemical properties is because they have the same number of valence electrons. They have the same number of valence electrons. Okay, so valence electrons is actually referring to what? It is actually referring to the number of electrons in the outermost shell. Okay, the next one, they're gonna ask you about color. So they like to ask colors. They always ask colors and also the physical states for group 7 elements. Okay, so before we touch the color, before we touch the color, we have to know about the physical state first. Let's do the physical state first. So fluorine, it is gas. Chlorine, it is gas. So bromine here, you have to know that bromine is the only liquid in halogens. So whatever is below the element bromine, like for example astatine, okay, it is solid. Okay, so now let us talk about the color. Okay, the color of fluorine, you already know, is pale yellow. What about chlorine? Okay, chlorine, it is pale yellow green. Okay, what about bromine? Bromine, it is red brown. Okay, all these colors you have to remember. Okay, it is very important for group 7 because there are many colors. Okay, so the next one. Okay, bromine has 2 naturally occurring isotopes. Okay, so state the term given to the numbers 79 and 81. Okay, so the numbers above here, they are obviously called nuclear number. Okay, you have to know this. Okay, so this is nuclear number or mass number. So it is either one. You can mention either nuclear number or mass number. Okay, so do you remember what is nuclear number? Okay, nuclear number is the total number of protons plus neutrons. So isotopes, what's the meaning of isotopes? Isotopes are, okay, what are isotopes? What isotope? Okay, what are isotopes? Isotopes are atoms of the same element having the same number of protons but different number of neutrons or nuclear number. Okay, to identify how many protons, how many neutrons, and how many electrons. Okay, so protons, we can have a look at the periodic table. Okay, where is bromine? Okay, bromine, you know, is group 7, so it has to be here. It has to be here. So bromine, it is 35. Okay, So it is 35. We're going to put 35 here because we know that isotopes have the same number of protons but different number of neutrons. Okay, so neutrons here, how are we going to calculate it? We're going to take 79 minus 35, and here we're going to take 81 minus 35. So we're going to get 44 and 46. Okay, what about electrons now? Okay, electrons here, since this is a neutral atom, is gonna be the same. So proton number is equals to the number of electrons. So we're gonna put 35 here. Okay, what about electrons on the other side here? Okay, electrons, it would be 35 plus 1 because of the negative charge here. Okay, so it's gonna be 36. Okay, so let us move on to the next part here. For this question, right, this is also another calculation whereby we have relative abundances of two naturally occurring isotopes of bromine. So they have already given you the percentages. So what are you going to do? It's very simple. You're going to take 79 times 55% plus 81 times 45%. Okay, so here is going to be 79 times 0.55 plus 81 times 0.45. And you get 79 times 0.55 plus 81 times 0.45. And you'll get 79.9. So this is your final answer. 79.9. Okay, the next question is, chlorine displaces bromine from aqueous potassium bromide but does not displace fluorine from aqueous sodium fluoride. So right now you have to write the symbol equation. Okay, the symbol equation is chlorine. Okay, so chlorine, it is halogen. So halogen is in group 7 and they always exist in diatomic molecules. So you have to put Cl2 plus aqueous potassium bromide. So we have KBr. So what are you going to get is this chlorine is going to displace bromide. It's going to take over the position here to form KCl. And what is the remaining one would be bromide. But not bromide, but bromine gas. It's going to release bromine gas. Okay, because this is left over and you know that bromine, it is also diatomic. So you have to put Br2. Okay, so now you have to put the physical state. Okay, if you only do this, you may only get 1 mark because you have written only the reactants and products. The next step is, okay, before the physical state, you have to balance it. Okay, this is still not balanced yet. So Cl2, obviously you can see here it's not balanced, so you have to put 2 for Cl2. And since K is not balanced, so you have to put 2 here also. Okay, now the next one is the physical state. So this is gas. And we know that this is aqueous, so this is aqueous. So this has to be aqueous too, and this is gas. Okay, so the next question is, state why chlorine does not displace fluorine from aqueous sodium fluoride. Okay, so it does not displace is because, okay, so the position of chlorine, bromine, and fluorine in the periodic table is Cl, Br, and F. Okay, so because chlorine is above bromine, so it can actually displace bromine, whereas fluorine is above chlorine, so chlorine cannot displace fluorine because we know that the reactivity decreases down the group. Okay, so you should explain here, because chlorine is less reactive. You cannot stop here. You have to write less reactive than fluorine. You have to make it very clear. Okay, the next one. Aqueous silver nitrate is a colorless solution containing silver ions. So, describe what is seen when silver nitrate is added to sodium chloride. Okay, so sometimes you do not know what will be seen. What you have to do is you have to write down the equation. So we have silver nitrate, AgNO3 plus sodium chloride. And what is it going to form? AgCl and NaNO3. So this is aqueous. This is aqueous. This is solid. Why? Because all chloride ions are soluble except for silver and lead. Okay, these are the things you have to memorize also about solubility in salts. Okay, so this is a precipitate because it is insoluble, whereas this is aqueous. Okay, so this is not solid. Sodium nitrate is not solid because we know that all nitrate ions are soluble. So this precipitate here form, it is actually white color, so we can mention that it's white precipitate. Okay, white precipitate is formed. Okay, so next one is ionic equation. Okay, ionic equation is like this. We have, okay, I'm going to write this down again. AgNO3 equals plus NCl equals, you get AgCl solid and NaNO3 equals. Okay, so I'm going to teach you a proper way how do you actually write the ionic equation. So aqueous, we're going to put Ag positive NO3 minus, aqueous also the same thing. But for solid, cannot because there are no free moving ions inside a solid. Whereas aqueous, we can do that too. So what are not involved here? Include sodium, we can cancel out. NO3, we can cancel out. So what's left behind? So this is left behind. Okay, so you can actually copy back. So when you copy back, it's going to be Ag positive aqueous plus Cl minus aqueous, and you get AgCl solid. This is how you actually do it. Okay? Okay, let's move on to the third question. Okay, over 200 million tons of sulphuric acid are manufactured every year. Okay, let's move on to the next question. Over 200 million tons of sulphuric acid are manufactured every year. So you have to name the process used to manufacture sulphuric acid. Okay, so there are two main processes. Okay, two main processes. Okay, there are two main processes that you have to actually remember. Okay, let me repeat again. Let's move on to the next question, which is question 3. Okay, so here we can surely look at this question. State the name of process used to manufacture sulphuric acid. Okay, this process here, right, is under the reversible chapter. Okay, it's under topic, I think it's topic 7, chemical reaction. So there are two main processes that you have to remember. So first one is for the production of sulphuric acid. Another one is for the production of ammonia. So for the production of sulphuric acid, the process name is called contact process, whereas for the production of ammonia is called Haber process. Okay, so here you have to write contact process. Okay, so describe two methods by which sulfur dioxide is obtained. So there are two methods. Okay, so the first method, it is burning sulfur. Burning sulfur where? In air. Okay, another one is roasting sulfide ores. Okay, so here, right, they're gonna ask you sulfur. We know that sulfur, we need these two methods: burning sulfur in air, roasting sulfide ores. What about oxygen? Okay, oxygen, we can get it from air. Literally air. Okay, so just a bit of recap. Okay, what about ammonia? Ammonia, we have NH3. How do you get nitrogen? Nitrogen, you also can get it from air through fractional distillation. H, or H, is through burning of methane. Okay, this is just a very quick recap. Okay, so right now, the next one. This is the first step actually. Okay, we have sulfur dioxide reacting with oxygen gas to form sulfur trioxide. Okay, so state two features of an equilibrium. Okay, this is a very frequently asked question. Okay, so the first one you have to know is the rate. Okay, second one is concentration. Always remember rate and concentration. So what rate? Okay, rate of forward reaction. Okay, forward reaction is referring to this, from left to right, whereby reactants form products. So this is forward. What about the other way? The other way is reverse. So this is reverse. So first one is rate of forward reactions is equal to the rate of reverse reaction. Second one, it would be the concentration of products and reactants remain constant. Okay, so I'm going to write here rate of forward reaction goes to the rate of reverse reaction. The second one is the concentration of products and reactants remain constant. Okay, the next one, state the typical conditions and name the catalyst used in this conversion of sulfur dioxide to sulfur trioxide. Okay, so temperature for, okay, I'm going to do comparison. Okay, this is for sulphuric acid, for the production of sulphuric acid, H2SO4. This is for ammonia. Okay, temperature is the same, 450 degrees Celsius. Ammonia is also the same. Okay, what about pressure? Pressure, it would be 200 kilopascal. Remember, 200 kilopascal or 2 atm. 2 atm is atmospheric pressure. Whereas for ammonia, it would be 20,000 kPa or 200 atm. Okay? Okay, so the next one, catalyst. Okay, so catalyst for sulfuric acid, it would be vanadium 5 oxide. Remember this. Remember to write the 5 there. Okay. Okay, what about ammonia? Ammonia, it will be iron. You can also write finely divided iron. It's the same thing. Okay, so let us take a look at this question. Okay, so it's the same. We have sulfur dioxide converted to sulfur trioxide, and they let you know that the forward reaction is exothermic. Same goes to ammonia. Okay, so when the production of ammonia, we have nitrogen gas react with hydrogen gas, we get ammonia gas. Okay, so that reaction is also exothermic. But here is good enough. They already give you the information that this is exothermic reaction for forward reaction. So when forward reaction is exothermic, the other way around will be endothermic. Okay, so here we have the table. They are asking you to use words increase, decrease, or no change. Okay, so here we have 3 different factors. We have temperature, we have pressure, and catalyst. Okay, so for rate of reaction, is referring to the first column, whereas for the second column, they're talking about equilibrium. So there are 2 different things. Okay, so for rate of reaction, it is always directly proportional. So what I mean is when temperature decreases, rate of reaction will also decrease. When temperature increases, rate of reaction will also increase. Same goes to pressure. So when pressure increases, of course, rate of reaction will increase. No catalyst will decrease. When there is catalyst, it will increase. Okay, so this part you understand, right? Because rate of reaction is more direct. Okay, so let's take a look at concentration now of the sulfur trioxide that is being produced. So concentration of sulfur trioxide that is being produced here is actually referring to the yield. Okay, so and we have to focus on equilibrium. Okay, so the first part here is actually about temperature. Okay, so when we talk about temperature, right, and they want you to focus on the forward reaction, because here we are looking at the yield. Okay, so what will actually favor exothermic? Exothermic, right? Okay, remember not equilibrium. Okay, the concept of equilibrium is always opposite. So temperature decreases, it will favor endothermic or exothermic. It will definitely favor exothermic. Okay, so when it favors exothermic, means that it's actually favoring the forward reaction. Because it's favoring this exothermic, so it is forward reaction, then of course the yield will actually increase. So this will be increased. What about pressure? Okay, pressure is different thing. Pressure is not about exothermic or endothermic. Pressure is about favoring the number of molecules. So when pressure increases, it's gonna favor less molecules. So on the left hand side of the equation, how many molecules are there? We have 2 and we have 1 here, so total is 3. And on the right hand side here of the equation, we have 2. So which side has lower molecules? on the right side. So this means that when pressure increases, it's going to favor the side with lower molecules, which is the right hand side. So this means that it will favor forward reaction, making the production of yield higher. So it will also be increased. So what if there is no catalyst? Will there be any changes? This is the only question you have to take note, okay? For catalyst, right, catalyst will increase forward reaction, but it will have no effect on the equilibrium, so it will be no change. Okay, so just in case you guys are confused, okay, let me explain a little bit more on temperature here, because temperature, let's say when temperature decreases, we know that it's gonna favor exothermic, so it's gonna favor the position of equilibrium is gonna shift to the right, so causing yield to increase. Let's say, for example, temperature increases. So temperature increases, we're gonna favor endothermic. So endothermic position of equilibrium is gonna shift to the left, so which means that the yield of the reactants will actually increase, causing the yield of the product to decrease. Okay? Okay, let us take a look at the next question. Explain in terms of collision theory why reducing temperature decreases the rate of forward reaction. Okay, so here we have collision theory. So you have to talk about the collision. You have to mention about the collision. The next one is the temperature. Okay, temperature and also the rate of forward reaction. Okay, so whenever there is the factor temperature, you have to actually know that it has to do with the movement of particles. So when temperature increases, it will cause the movement of particles to increase too. Okay, so when temperature decreases, it will cause the movement of particles to decrease. So the movement here is actually referring to what energy? It's actually referring to kinetic energy. So when temperature decreases, it will actually cause the kinetic energy to decrease. So kinetic energy of particles decreases. Okay, now what about the collision? Okay, so when kinetic energy of particles decreases, it will actually cause the frequency of collisions to also decrease. So the next one is frequency of collisions also decreases. Okay, the next point would be you have to talk about the activation energy. Why? What is activation energy? Activation energy is the minimum energy to start a reaction. Okay, so we have to explain this. So activation energy, so because there is fewer frequency of collision of particles, so this will actually cause fewer particles will have higher energy. Than activation energy. Okay, let's move on to the next one. Sulphuric acid contains sulfate ions. So the oxidation of oxygen atoms in sulfate ions is -2. Right now they're asking you what is the oxidation number of sulfur. Okay, so you have to show your working. You cannot directly just tell the answer. So what you can do here is, okay, we know that the total oxidation for sulfate ion, it is -2. Okay, they already give you the oxidation number of oxygen here is -2. So here it would be, okay, so the total oxidation number of sulfate ion is 2. Okay, so we have to look for this. Okay, so what you can do is you put sulfur plus 4 is referring to the number of atoms here of oxygen. So you're going to put -2 equals to -2. So S, just do the simple math calculation. So it's 2 plus 8 and we get +6. So the answer is +6. Okay, let us move on to the next question here. Okay, solid sodium hydroxide is a base which dissolves to form aqueous solution, sodium hydroxide. So what is meant by the term base? Okay, so this is a very frequently asked question. Okay, so they always ask you, what is the meaning of base? What is the meaning of acid? Okay, so when it's 1 mark, you should know what you should answer. Okay, so for term base, it is proton acceptor. Okay, why? Okay, how can you actually memorize? Okay, actually there's a reason behind it. Okay, maybe I can explain it to you. If you do not need any explanation, you can skip further. Okay, so here, right, acid. Okay, we know that acid is a chemical substance that ionizes in water to produce hydrogen ions. Okay, so hydrogen ions here is actually referring to proton. Why hydrogen is proton? Okay, so I'm gonna write it here. Okay, so I'm gonna put proton donor. Now the question is why hydrogen is proton? Okay, because this is the chemical formula based on the periodic table, right? So this is proton and this is nucleon. Okay, so you know that nucleon is equals to proton plus neutrons, but here we already know that hydrogen has one proton, so we can conclude that hydrogen does not have any neutrons. So with that, we can actually also conclude that hydrogen is a proton. So acid has to be proton donor, okay, because this one is actually referring to hydrogen. Okay, why acid is a proton donor? Like what I've said, acid ionizes in water to produce hydrogen ions. So if the other way round, base is a proton acceptor. State the term given to a base which dissolves to form an aqueous solution. Okay, so this has to be alkali. Okay, so you have to know that alkali is a subset of base, which means that all alkali is a base, but not all base is an alkali. Okay, so state the color of thymophytolene in sodium hydroxide. Okay, the color of thymophytolene in sodium hydroxide, it is blue in color. This is something that you have to memorize. Okay, so what about phenolphthalein in alkaline solution? Because this we know is alkaline because of the hydroxide. So for phenolphthalein, it is pink color. So what about acid and neutral? So for acid and acidic or neutral solution, it's going to be colorless for phenolphthalein and phenolphthalein. Okay, so it's only for alkali. Okay, so here the next one is for the reaction of sodium hydroxide and ammonium chloride. So when sodium hydroxide reacts with, this is an alkali, reacts with ammonium salt, what are you gonna get? You're gonna get salt, water, and ammonia gas. Okay, this you have to take note. What if it is an acid? If acid react with ammonia, you're gonna get ammonium salt, only ammonium salt. Okay, so this is something that you have to remember. Okay, so let's focus on this question. So we have NaOH and so ammonium chloride. We'll get sodium chloride, water, and ammonia. Okay, now the next question. State the term given to metal oxides which react with bases such as sodium hydroxide. Okay, so the term that is given when it reacts with bases is acidic oxide. So name an oxide, a metal oxide, which reacts with sodium hydroxide. So because usually metal oxide, it does not react with sodium hydroxide, but there's a special one which we call it as amphoteric oxide. So amphoteric oxide, the next question. Some metal oxides react with sodium hydroxide. So this one is about what? This one is about the chapter basic oxide. We have acidic oxide, and we have amphoteric, and we have neutral oxide. So basic oxide, we know that is metal oxide that reacts with acid to form salt and water. Whereas acidic oxide is, you have to react with alkali to form salt and water. So this is like a neutralization process. Whereas for amphoteric oxide, it can react with both acid and alkali. Neutral oxide, it cannot react with acid and alkali. Okay, so coming back to this question, so state the term given to metal oxides that react with bases. So it's usually non-metals that react with bases. Okay, so but for some metals here, which one are you referring to? You're referring to amphoteric oxide. Okay, because it can react with both. So it is amphoteric oxide. So name an example of amphoteric oxide. It would be zinc oxide, or you can call it as aluminium oxide. So these two are the famous ones that you can actually write. Okay, so move on to the next part here, ethanoic acid. Okay, ethanoic acid is actually a very famous acid, okay, like vinegar in your household. So it's a weak acid, and right now I'm going to show you how you can actually draw this dot and cross diagram. Okay, so we can actually start off by doing the hydrogen. Okay, so we know that hydrogen itself, it has one proton, which means that it has one electron. So you can draw it here, because this is actually part of its shell, this circle. So I'm going to put it here. And why I put it here is because it's going to share electrons with the carbon later. So I'm going to put it here first. Okay, so now we can actually do carbon. Okay, carbon here, since it put dot, so I'm going to put dot here, because they are actually sharing. So when there is one, so this is called as one pair. So it always in the form of pairs. Like let's say hydrogen share one, the other person is going to share one too. Let's say for example, when there's one atom that shares two, the other atom also has to share two. So it always comes in pairs, okay, because this is a covalent compound. Okay, why is it covalent? It's because hydrogen and carbon, they are non-metals, so they form a covalent compound here. Okay, so we have, okay, so since this circle, this entire circle, there are two electrons, two electrons, two electrons, this is already balanced. For hydrogen, balance, balance, balance. Okay, now let us take a look at carbon here. So how many carbon? We need 8 electrons in the second shell. So we have 1, 2, 3, 4, 5, 6. We need 2 more. So we're gonna put 1 here and 1 X here. So this X here is referring to the second carbon here. So this is also balanced already, because now we have 1, 2, 3, 4, 5, 6, 7, 8. So this carbon is also balanced already. So let us move on to the second carbon right now. Okay, the second carbon here, we're gonna use X. Okay, so X, we're gonna put 1 X here. Okay, of course, when there is 1 X here, we're gonna put 1 0 here, 1 dot here. Okay, so here we're gonna put 1 X here, because you can tell that they are actually sharing something. So I'm gonna put 1 0 here, because of the oxygen here. It always comes in pairs, remember that. Okay, so how many are there? 1, 2, 3, 4, 5, 6. We need another 2 more, because we need 8 electrons in the second shell. So we're gonna put X, X. So this is already balanced. Okay, so there's one more hydrogen here, so we can actually put X dot. Okay, so this is also balanced already. So I'm gonna put balance, balance. Okay, let's do this oxygen here. Okay, so this oxygen, how many are there in the second shell? 1, 2, 3, 4. So we need another 4 more. So we're gonna put 1, 2, 3, 4. Okay. Okay, so let us look at here now. Okay, so how many are there in the second shell of the oxygen? 1, 2. So we're gonna need another 6 more. So it's 1, 2, 3, 4, 5, 6. So this is how you actually draw the dot and cross diagram. You can actually calculate again, like to make sure that there are 8 electrons in the second shell and 2 electrons in the first shell. Okay, so right now you have to suggest the pH value of dilute ethanoic acid. So we know that dilute ethanoic acid, you cannot write very low pH, right? So it will be better for you to write from 3 to 7. Okay, do not write 0 to 1. It will be safe for you to write in. Okay, so we know that pH value is from 0 to 7 to 14. So try to write around here because here is weak acid, whereas 0 to here is strong acid. So I would suggest you to write 5. Okay, right now you have to write the dissociation of ethanoic acid. Okay, we know that ethanoic acid is a weak acid, so it's gonna partially dissociate. So when partially dissociate, you're gonna put this symbol. This is the same symbol as reversible reaction. So it's gonna ionize in water to produce hydrogen ion because it's an acid. So we can put H positive plus what is remaining here, CH3COO. So this is called ethanoic ion. So the next question is, write the ionic equation for a reaction when acid neutralizes solid base. Okay, this is very simple because we know that acid is gonna neutralize soluble base to form water. So water is liquid, so it's definitely H positive plus OH minus. So this is aqueous, and this is liquid. The next question, in titration we have volume, concentration, 25 cm cube of 0.08 mole per dm cube potassium hydroxide neutralized by 20 cm cube of dilute sulphuric acid. So right now you have to calculate the concentration using the following steps. Okay, they have clearly provided you the steps, so it will be easier actually. So now you have to calculate the number of moles of potassium hydroxide. Okay, potassium hydroxide, we have 25 cm cube and we have 0.0800 mole per dm cube. Okay, here it's concentration, we have number of mole, and here we have volume. Okay, number of mole equals to what? So what you're going to do, you're going to times this, so equals to concentration 0.0800 mole per dm cube times 25 cm cube. So careful here, cm cube, so if you want to convert it to dm cube, you have to divide by 1000 dm cube. So you can cancel and you'll get, okay, 0.0800 times 25 divided by 1000. Okay, you're gonna get 0.002 mole. Okay, the next question here is, determine the number of moles of H2SO4 will react with KOH. So we know that there is 0.002 mole of KOH based on this, the previous question. It will react with 0.002 divided by 2 times 1, so equals to 0.001 mole. Okay, why 2 here is because of here, whereas here only has 1, so you have to divide it by 2 times 1 mole of the sulphuric acid to get 0.01 mole. Okay, the next question is concentration now. So concentration again, we know the number of mole of sulphuric acid, so there is 0.001 mole. Okay, to calculate concentration, it is C equals divided by, C equals to mole divided, this is mole, divided by volume. So volume, it is, what's the volume of sulphuric acid? It is 20, but you have to divide by 1000 to get the m cube. So you calculate 20, 0.001 divided by 20 divided by 1000, and you get 0.05 mole per dm cube. Okay, so the next question is concentration of sulphuric acid in gram per dm cube. So it's mole per dm cube, and right now you want it to be gram per dm cube. you want to change it to gram per dm cube. And what you have to do is, you have this already, so you have to change this mole to gram. So how you want to change mole to gram is you times the molar mass. So it is 0.05 mole per dm cube times the molar mass. So it's 2, 1 plus 32 plus 4, 16. So this you can actually refer it to the periodic table. Okay, so here we have 2 plus 32 plus 64. So you get 0.05 times 98 equals to times 0.05 equals to 4.9. So your final answer is 4.9. Okay, so moving on to the next part is question 5, which is organic chemistry. Okay, so we have alkane, which is propane, and one alkene, which is propene, both react with chlorine. Okay, so the first question is, we have a molecule of propane reacting with chlorine in the presence of UV light. One atom of hydrogen is replaced by one atom of chlorine. So they are asking you, state the term given to the reactions in which one atom in an alkane is replaced by another atom. So this replace here is actually referring to what? It's actually referring to a chemical reaction called substitution reaction. So this is substitution reaction. Okay, so what's the purpose of this UV light here? Okay, so this UV light here is actually to provide activation energy. Okay, the next question, state the term given to any reaction which requires UV light. Okay, so the light here gives you an idea of photo. So it's photochemical reaction, because we know photo means light. Like for example, photosynthesis means light. So this is actually photochemical reaction. Okay, so the next one is, write the simple equation for the reaction between propane and chlorine. Okay, so propane, the general formula for alkane, it is CnH2n plus 2. So how many carbon is that? Right, it is pro. It is 3. So it is C3H6 plus 2 equals to C3H8. Okay, so this is the formula of propane. Okay, so when it reacts with chlorine, is this the right one? No, because chlorine is a diatomic molecule. Okay, it's group 7, so it has to exist in diatomic form, so which is Cl2. So you're gonna form what? Okay, so they already mentioned that one atom of the hydrogen is replaced by one atom of chlorine, so which means that the propane is gonna lose one hydrogen, okay, and receive one chlorine. So it's gonna be CH7 because it loses one, and it will accept one chloride from the chlorine gas to form C3H7Cl plus what is remaining is the one hydrogen that is being released from the propane, and the other one chloride to form hydrogen chloride here. Okay, so next question is, why propene is an unsaturated molecule? We know that alkene, they are unsaturated because they do not contain all single carbon bonds, okay, because it has carbon-carbon double bonds. Okay, you can mention that it has carbon-carbon double bonds. Okay, so the next one is, give the structural formula of the product of this reaction. Okay, so we have propene reacting with chlorine. So to make it easier, you can actually draw it out so that you can actually write the structural formula. So propene, how would you draw it is, you put C, 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 C. There are 3 carbon, but because it is unsaturated, it has at least one double bond. Okay, I shall put it here. Okay, so now you're going to put all the hydrogen. Okay, so this carbon here, 1, 2, 3, 4, so it's hydrogen. 1, 2, 3, 4, hydrogen. 1, 2, 3, 4, hydrogen. So this is actually propene. Okay, so when it reacts with when it reacts with ClCl, it's gonna break this bond here. Okay, so when it breaks this bond here, it's gonna form. Okay, you can draw it this way again. So this remains HHH, and here. So it's gonna break it to form two bonds here. So it's gonna put H, you put Cl, H and H. So this is how you draw it. Okay, so how you're gonna do the structural formula here is actually you can separate this way. Okay, so this is how you can actually write it. So you have the first part here, you can put CH3 because there are 3 hydrogen atoms. The second part here you put C, and there's 2 hydrogen atoms here. Okay, the next part here. Okay, the next part here we know that there is 2 hydrogen atoms, so you can put C first, then H2 and Cl. So this is actually the structural formula of the product. Okay, the next one is propene undergoes addition reaction with steam. Okay, so when an alkene undergoes addition reaction with steam, it's gonna form alcohol. Okay, so how can you actually do this? Okay, you can actually draw it out again. Okay, we have propene. Okay, and then it adds with steam to form alcohol. Okay, so if we know that it's gonna form alcohol, we can actually write down the general formula of alcohol first so that we can actually double check. So general formula of alcohol is CnH2n plus 1OH. So for propene, right, it's gonna form what kind of alcohol? It's gonna form propanol. Okay, so we're gonna put C3H7OH. So this is actually for your later on when after you draw, you can actually double check again. There are 2 possible ways because they already mentioned there are 2 possible products. So one of the product that can be formed is this. Okay, like for example here, this is one of it. Okay, so how is it gonna form is, okay, this thing can actually break down. Okay, when it adds with steam, so it's gonna be OH. Either this way or it can be okay, so it can actually break down to form here. Instead of OH here, OH can be here. So there's a name for this. Okay, so we know that this is gonna be propanol. Okay, but it really depends on where you're gonna put the hydroxyl group here. Okay, so here we have to name it from the list, from the beginning of the first carbon atom here. So this is 1, 2, and 3. Because this is on the first side here, we should name it propan 1-ol. Okay, what about this? We can put 1, 2, 3 or 1, 2, 3. Either way, it's still gonna be number 2. Okay, this one we can't put it 3 because we have to pick the least number here. That's the rule for it. Because you can imagine that this thing, right, when you, okay, like for example, this 3, okay, there are 3 carbon atoms and then the hydroxyl group is here on the left side, but it can actually move back to here. So it's the same side actually. So always go for the least number here, number 1. Okay, so for the second one, it's gonna be propan 2-ol. Okay, so this is the final part, the final question, question 6. Okay, we have carboxylic acids can be converted into ester. So right now they're asking you to name the ester form when butanoic acid reacts with alcohol, which is ethanol here. Okay, so when it comes to naming ester, right, we have to start with the alcohol name first. Okay, so ethanol, so it has to be ethyl, and then followed by the carboxylic acid, which is butanoic. We have to change it. So we know that this ethyl comes from the alcohol, butanoic is coming from the carboxylic acid. Okay, so another product that is formed in this reaction, it is called water. Okay, so this one we know when you calculate this, right, CCC, so it's C3H C3H7COOH. So this is butanoic acid, whereas ethanol is C2H5OH. So when they add up together, it's gonna form ethyl butanoate, which is, so this is gonna combine with this to form water. So we have here C3H7COOC2H5. This is the chemical formula for ethyl butanoate, and then the remaining is water. This is how the other product is being formed. Okay, right now they ask you, did you use the empirical formula of the ester form? So this, you have to simplify it. How you simplify it is, you can basically just calculate the total number of carbon atoms that is present in this ester. So we have 3 plus 3 plus 1, 4 plus 2, so it's C6. How many H are there? 7 plus 5, you have 12, and there is 2. So when you simplify it, you can simplify it by dividing everything by 2, and you'll get C2H6O. So this is the final answer. Okay, so moving on to the next one is PET is a polyester. Part of the structure has been drawn here, and right now they are asking you to circle one repeat unit of this polymer. We know that ester, it's the combination when carboxylic acid reacts with alcohol. Okay, so that's one of each. But when it's a polyester, of course we need more than one of each side, which is more than one carboxylic acid and more than one alcohol, because of this word many here. Okay, but right now they want you to circle one repeat unit, so minimum you have to have 2. Okay, 2 of each side. So we have, this is what we call it as carboxylic acid. Okay, this comes from carboxylic acid, and the O here is from alcohol. So you have to circle it. So it's from here to here. Only here, it's just only here. Okay, so right now the next question is, they ask you to draw the structures of the monomers which make up the PET. So they're asking for this right now, this and this, the monomers, how they actually form. Okay, so we can draw this. The O, we know it is from the alcohol, and here it's from the carboxylic acid. So this is OH. So that's the reason why when we add these two together, okay, this is your final answer, but let me do some explanation. Okay, so here, so once this is being removed, it's gonna be water. So when water is being removed, right, you see, and let's say water is being removed, and then you combine these together, this is how you actually formed here. Okay, so this is just an explanation. Okay, so state this type of polymerization used in making PET. So this type of polymerization is what we call it as condensation, because condensation is going to release water. Okay, so that's the answer. So if you have any questions, you can leave in the comments below. Okay, thank you. See ya. Bye bye.